Picture this: a lone ship cutting through the endless black of the ocean at night, its crew trusting nothing but the shimmering patterns above and a handful of carved instruments to find their way. No satellites, no compasses, no weather apps, just human ingenuity and centuries of hard-won knowledge passed down through generations. These ancient navigators didn't just survive on the open sea, they thrived, decoding messages in the stars that told them when storms would rage, when crops would fail, even when empires might crumble. And here's the astonishing part: their tools weren't just about finding north or south. They were windows into the very fabric of the universe, blending science, myth, and survival into something far greater than the sum of its parts. What if I told you that a simple wooden disc or a carefully notched stick could predict disasters years in advance? That's the power these ancient mariners wielded, tools so precise they could track the movements of planets, anticipate monsoons, and sense shifts in the Earth's magnetic field long before modern science caught up. These weren't just gadgets, they were lifelines woven into the stories and rituals of cultures from Polynesia to the Mediterranean. And yet, somewhere along the way, we forgot their true significance, dismissing them as primitive when they were anything but. So why does this matter to us today? Because in a world where climate change reshapes coastlines and technology fails us when we need it most, there's wisdom in looking back. These navigators didn't just read the stars, they listened to them, understanding patterns we're only now beginning to decode with supercomputers. Their knowledge wasn't just about survival, it was about harmony with forces far beyond human control. And as we unravel their secrets, we might just find answers to questions we didn't even know to ask. This is the story of how the past could light our way forward, and it starts with a single voyage into the unknown. The Polynesians didn't just sail, they danced with the ocean, reading wave patterns like musical notes while their star compasses transformed the night sky into a living map. Picture a wooden board with strings called a kamal, used by Arab navigators to measure star angles with startling precision. By holding one string between their teeth and adjusting another to align with the horizon, they could calculate latitude without a single modern instrument. Meanwhile, Viking sunstones, legendary crystals that polarized light, allowed them to locate the sun even through dense fog, turning overcast days into navigational opportunities rather than disasters. What's truly remarkable is how these tools doubled as timekeepers. The Astrolabe, perfected by Islamic scholars, wasn't just for direction. It could predict sunrise and sunset times, track zodiac signs, and even determine prayer hours. These weren't isolated inventions. They were part of a global tapestry of knowledge. Polynesian navigators memorized hundreds of stars and their seasonal shifts, knowing that when the Pleiades cluster dipped low, it signaled the start of storm season. The Vikings, on the other hand, relied on mythical sun dogs, atmospheric halos that hinted at coming weather changes. But here's what modern science often overlooks: these techniques weren't just practical, they were sacred. The Maori of New Zealand saw the Milky Way as the hull of a celestial canoe, guiding spirits to the afterlife. Norse myths described the aurora borealis as the armor of dead warriors, shimmering warnings of winter's approach. For these cultures, navigation was a dialogue with the divine, where every star and storm carried meaning beyond mere survival. And that's the real secret behind their accuracy. Unlike today's detached, data-driven systems, ancient navigators lived in constant conversation with their environment. They noticed when bird migrations shifted earlier than usual, signaling distant droughts. They observed how coral reefs emitted faint vibrations before earthquakes, a phenomenon modern seismology confirmed centuries later. Their tools weren't just instruments, They were extensions of a world view where humans and nature collaborated rather than competed. So when we call their methods primitive, we're missing the point entirely. These navigators didn't just predict the stars, they listened to them, forging a bond between Earth and sky that modern technology still struggles to replicate. Their legacy isn't just in the tools they left behind, but in the radical idea that the universe speaks if we're willing to learn its language. To understand how deeply these ancient cultures intertwined with the cosmos, consider the Polynesian star compass not a physical object, but a mental map dividing the horizon into 32 houses where stars lived. Each rising and setting point held meaning, creating a celestial calendar that told them when to plant taro, when to expect tuna migrations, even when to avoid long voyages due to hurricane winds. This wasn't guesswork, it was precise observational science honed over generations. When the star Arcturus appeared directly overhead, Hawaiian navigators knew it marked the beginning of Makahiki season, 4 months of peace, harvest, and tribute. Meanwhile, in the Marshall Islands, sailors created stick charts from palm ribs and shells, not to carry aboard canoes but to teach wave patterns. The shells represented islands, the curved sticks showed how swells refract around land, creating a hydrodynamic map etched in memory long before satellites could image such patterns from space. The Maya took this further, turning their temples into astronomical instruments. At Chichen Itza, the pyramid of Kukulkan casts a shadow serpent that slithers down the steps during equinoxes, a stone calendar marking the transition between rainy and dry seasons. Their Dresden Codex contains Venus tables so accurate they could predict the planet's appearances within hours across 500 years. But here's what modern archaeology often misses. These weren't just scientific records. Venus was Kukulkan, the feathered serpent god, and its movements signaled when to wage war or plant maize. The sky wasn't separate from daily life, it dictated it. Compare this to Norse navigation myths, where the aurora wasn't just pretty lights, it was believed to be the breath of warriors, its colors hinting at coming storms. Their sagas describe vindstiki, mysterious wind arrows in the sky that preceded gales by days. Modern meteorology now recognizes these as jet stream cirrus clouds, but Vikings didn't need satellites to read them. They simply paid attention, noticing how certain cloud formations meant fair winds while others warned of blizzards. What united these cultures was their holistic view of the cosmos. They didn't compartmentalize astronomy from agriculture or spirituality the way we do today. When Tongan navigators saw the Pleiades dim slightly, what we now know is caused by interstellar dust. They interpreted it as the god's displeasure, prompting societal reflection. Modern astronomers confirmed this dimming occurs cyclically every few centuries, matching records of Tongan political upheavals. Coincidence, perhaps? Or perhaps they recognized patterns we're only beginning to quantify with spectral analysis. The real genius of these systems lies in their redundancy. Polynesians didn't just rely on stars, they watched bird flight paths, ocean phosphorescence, even the way clouds clustered over unseen islands. The Inuit read snowdrift shapes to predict blizzards, while Aboriginal Australians used emu egg-laying cycles to forecast droughts. This multi-layered approach created fail-safes modern GPS lacks. When one signal was obscured, another could guide them. It was science woven into story, observation married to tradition, a reminder that the oldest predictive tools weren't devices, but disciplined ways of seeing. Storm prediction was an art form for ancient navigators, a language written in clouds and waves long before radar or satellite imagery existed. Take the Polynesians, who could sense a coming storm days in advance by watching the way cumulus clouds stacked like towers on the horizon, a phenomenon modern meteorologists now call convective buildup. They knew that when frigate birds flew inland instead of skimming the waves, it wasn't just a change in behavior, it was a warning. The birds sensed dropping air pressure, a sign of brewing cyclones, and the navigators trusted their instincts as much as any instrument. Viking sagas tell of sailors who could smell storms, a metallic tang in the air caused by ozone released from distant lightning. They watched the wave foam formed on wave crests, noticing that tighter, frothier patterns meant winds were strengthening. But their most ingenious trick involved something as simple as a bucket of seawater. By observing how quickly the water's surface tension changed, they could detect minute shifts in atmospheric pressure. If the water clung to their fingers differently than usual, a gale was likely on its way. Meanwhile, Pacific Islanders developed an almost musical relationship with the ocean. They recognized that swells had distinct rhythms. Long, rolling waves meant stable weather, while shorter, choppier intervals hinted at turbulence ahead. Some navigators could even identify storms hundreds of miles away by listening to the resonance of waves against their hulls, a technique later confirmed by acoustic oceanographers. The ocean didn't just move, it spoke, and these sailors understood its dialect. This knowledge didn't just keep ships afloat, it reshaped history. When the Polynesians settled Hawaii, they timed their voyages to avoid hurricane season by tracking the Pleiades' position. Viking raids often paused during certain lunar phases, when erratic tides made coastal landings treacherous. Even the collapse of the Greenland Norse settlements may trace back to ignored warnings. Ice cores show they disregarded Inuit advice about shifting sea ice patterns, clinging to European methods instead. What's astonishing is how precise these observations were. Modern studies comparing Polynesian storm lore with weather satellite data show an 80% accuracy rate matching early 20th century forecasts. They didn't need barometers because the world itself was their instrument. Every ripple, every shift in bird flight, every change in the wind's whisper carried data. And perhaps that's the real lesson. Prediction wasn't about controlling nature, but learning its rhythms so deeply that danger revealed itself long before it struck. The camel seems almost too simple to be revolutionary, just a small wooden rectangle with a string tied through its center. Yet this unassuming tool held the key to unlocking the sky's secrets. Arab navigators would hold one end of the string between their teeth, stretching it outward until the wooden board aligned with the horizon and a chosen star. By measuring the angle created, they could calculate their latitude with astonishing accuracy. But the real magic happened when they turned their attention to Polaris, the North Star. Unlike other stars that appear to move across the night sky, Polaris holds nearly fixed in position, becoming a celestial anchor point. What made the camel extraordinary wasn't just its ability to guide ships, it was how it transformed into a seasonal clock. Navigators noticed that Polaris appeared slightly higher or lower in the sky depending on the time of year. During summer months in the northern hemisphere, the star rode higher, signaling the approach of monsoon winds that would fill sails and carry ships between India and Arabia. When Polaris dipped lower, it warned of winter's dry trade winds, dictating when merchants should delay voyages or shift routes. This wasn't just navigation, it was cosmic forecasting, turning stellar positions into an agricultural and economic almanac. The camel's brilliance lay in its adaptability. Different knots along the string corresponded to key ports' latitudes, allowing sailors to measure their progress without complex calculations. A navigator bound for Calicut might use the third knot, while one heading to Zanzibar relied on the fifth. Over generations, these measurements became refined through oral tradition, blending astronomy with practical wayfinding. Unlike modern GPS, which gives coordinates without context, the camel forced its users to engage directly with the night sky, deepening their understanding of celestial rhythms. Perhaps most remarkably, the camel connected the vastness of space to daily survival. When Polaris appeared at a specific angle above the horizon, it didn't just mean a ship was on course, it signaled when to plant date palms in Oman or harvest pearls in the Persian Gulf. The sky wasn't a separate realm, it was a living map of earthly cycles, and in an era when most believed the heavens were the domain of gods, the camel's users demonstrated something radical, that the cosmos could be measured, predicted, and harnessed by human hands. This humble tool's legacy endures in surprising ways. Modern sailors still learn to shoot stars with sextants, and the principle behind the camel lives on in aviation's altitude indicators. But more than that, it reminds us that profound knowledge doesn't always come from complex technology. Sometimes it's carved into a piece of wood and knotted onto a string, waiting for someone to look up and understand. The astrolabe wasn't just a tool, it was a universe in the palm of your hand. Imagine holding a brass disc no larger than a dinner plate, etched with intricate patterns that mapped the entire night sky as it shifted with the seasons. Islamic astronomers like al-Biruni didn't just perfect its design, they transformed it into a portable observatory capable of solving problems that would stump modern computers without electricity. By sliding its movable parts, a user could calculate the height of a mountain, determine prayer times across continents, or predict when the Nile would flood based on Sirius's rising. Columbus carried one on his voyages, but its brilliance wasn't limited to exploration. In Cordoba's libraries, scholars used astrolabes to debate whether the Earth revolved around the Sun centuries before Copernicus. What made the astrolabe extraordinary was its duality. For sailors, it measured the sun's angle to navigate open seas. For farmers, its zodiac engravings dictated planting cycles, when to sow wheat as Virgo rose or harvest grapes under Scorpio's sting. Cities timed festivals to its predictions. Doctors even used it to chart critical days in illnesses, believing planetary alignments affected health. This wasn't superstition. Medieval Persian physicians documented faster recoveries when treatments aligned with astrolabe-guided schedules, a concept modern chronobiology now validates. The device didn't separate science from daily life, it wove them together, yet its decline tells a darker story. When European universities began prioritizing specialized instruments, quadrants for navigation, clocks for timekeeping, the astrolabe's holistic wisdom fractured. The very thing that made it revolutionary, its ability to connect stars to soil, medicine to tides, became its downfall in an age craving compartmentalized knowledge. Today, we're left with a haunting question. Did we gain precision at the cost of perspective? Modern GPS can pinpoint your location to a millimeter, but can't tell you when to plant crops based on Jupiter's position. The astrolabe's users understood something we've forgotten, that the universe operates in relationships, not isolation. Perhaps its greatest lesson lies in its design. Unlike today's black box technology, every calculation required turning the device, tracing celestial paths with your fingers, a tactile conversation between human and cosmos. To use an astrolabe was to participate in the mechanics of the heavens, not just observe them. In that sacred interplay, medieval scholars and sailors alike found something we're still searching for, not just answers, but a way to belong to the stars. Polynesian wayfinding wasn't just a method. It was a living conversation between human and ocean, written in stars and waves rather than ink. Picture an apprentice navigator spending years memorizing chants that encoded centuries of knowledge, not just star positions, but how the swell changed when land was near, how certain clouds clung to unseen peaks like mist on a mirror. Their star compass didn't point north, it pulsed with life, each of its 32 divisions tied to a celestial body, a wind pattern, even the taste of the air. When the star Hokula rose in the east, it didn't just mark direction, it signaled the season when mahi-mahi would school near Maui, when breadfruit trees would drop their bounty. What set Polynesian navigation apart was its fluid intelligence. Western compasses point rigidly to magnetic north, but a Polynesian wayfinder knew that stars shift their rising positions slightly each night, and that this subtle dance could reveal longitude long before European clocks cracked the puzzle. They detected islands long before sighting them by reading the ocean's language, how waves refract around land, creating interference patterns a trained eye could spot. A sudden change in swell direction might mean an atoll lay just beyond the horizon, while frigate birds flying low at dusk almost always betrayed land within 30 miles. Even bioluminescence spoke to them. Certain plankton blooms clustered near reefs, painting the sea with glowing highways to safety. This knowledge wasn't locked in books but lived in bodies. Navigators trained themselves to sense currents through their canoes' vibrations, to distinguish a dozen shades of blue in the water, each indicating depth, temperature, or the presence of distant land. When clouds obscured the stars, they navigated by tilapa of underwater lightning, faint streaks of light caused by volcanic activity near islands. Modern oceanographers only confirmed this phenomenon in the 1990s, but Polynesians had been using it for millennia. Perhaps most astonishing was the system's adaptability. Unlike the kamal or astrolabe, Polynesian wayfinding evolved with every voyage. New discoveries were woven into chants, updating the collective memory in real time. When Hokula, a replica of an ancient Polynesian canoe, successfully sailed from Hawaii to Tahiti in 1976 using only traditional methods, it proved something radical, that this primitive system could outperform modern instruments. GPS tells you where you are. Polynesian navigation told you where you were in relation to everything else: the stars, the seasons, the rhythms of life itself. Today, scientists study these techniques not just as history but as solutions. Polynesians crossed oceans sustainably for centuries, leaving no pollution, no wasted resources, only a deeper understanding of their world. In an age of climate crisis, their legacy whispers a challenge. What if advancement isn't about conquering nature, but learning to listen to it? The real treasure wasn't the destination, but the wisdom gathered on the journey. Viking sunstones weren't just tools, they were windows into a world where light itself held secrets. Picture a Norse navigator gripping a translucent calcite crystal, rotating it slowly against an overcast sky. Where modern eyes would see only gray, the sunstone revealed something astonishing. A faint, polarized glow marking the sun's hidden position, even through storm clouds. Physics explains this as Heidinger's brush, a phenomenon where certain minerals filter scattered sunlight to reveal its source. But to the Vikings, this wasn't just optics, it was magic woven into the fabric of their survival. The true genius of the sunstone lay in its dual purpose. While helping ships navigate the North Atlantic's treacherous fogs, it also served as an early warning system. Sagas speak of the solarstein darkening ominously before prolonged winters, a detail modern climatology now validates. Calcite crystals are sensitive to atmospheric changes. Shifts in humidity and temperature alter their light-bending properties. When the sunstone behaved unusually, it wasn't just a navigational aid, it was whispering of the Fimbulwinter, the 3-year winter said to herald Ragnarök. Ice core studies from Greenland show these legends may have roots in real events. Volcanic eruptions in the 9th century likely triggered abrupt cooling, remembered centuries later as the apocalyptic winter of myth. What's often overlooked is how these stones connected the practical to the sacred. Viking navigators didn't separate science from spirituality. A Sunstones readings weren't just data, they were messages from the gods interpreted by chieftains and shamans alike. The same crystal that guided a longship to Iceland might later be placed on a ritual altar, its behavior scrutinized for omens. This wasn't primitive superstition. It was a holistic understanding that environmental shifts carried cosmic significance. When the Sunstone hinted at coming darkness, it wasn't merely predicting weather. It was framing it as part of a larger narrative of destruction and rebirth. Modern experiments reveal just how precise these tools could be. Researchers using Icelandic spar, a type of calcite found in Viking graves, successfully navigated within 5 degrees of accuracy on completely overcast days. But here's the twist: the stones worked best when combined with other techniques. Sagas describe navigators using horizon boards, notched wooden slabs that tracked the sun's arc when visible, creating a memory of its path for cloudy days. Together, these methods formed a redundant system, compensating for each other's limitations centuries before engineers invented backup systems. The Sunstone's legacy challenges our assumptions about ancient technology. We imagine progress as a straight line from primitive to advanced, yet here was a culture using light polarization, a principle modern sunglasses wouldn't harness until the 1930s, to conquer the seas. Their tools didn't just solve problems, they wove together observation, tradition, and cosmology into a single thread. In an age where we've outsourced navigation to satellites, the Sunstone reminds us that the most profound technologies don't just show us where we are, they tell us who we are in the grand scheme of things. Ocean currents didn't just carry ships, they shaped civilizations. Picture a Polynesian voyager, not paddling against the waves but gliding effortlessly along the Kuroshio Current's liquid highway, covering thousands of miles with an intimacy modern sailors might envy. These weren't random routes, they were meticulously mapped through generations of observation. The Pacific Islanders knew that where the warm Kuroshio met colder waters, nutrient-rich upwellings attracted fish, a moving buffet that sustained voyages. Meanwhile, along the Mediterranean sun-drenched coasts, Phoenician traders rode the steady Levantine current like a maritime Silk Road, their ships laden with Tyrian purple dye and Lebanese cedar. But here's what's often missed: these currents weren't just convenient pathways, they were ancient climate records pulsing with warnings. When the normally reliable equatorial counter current faltered, Polynesian navigators recognized it as a harbinger of drought, a phenomenon we now link to El Niño events. Their oral histories tell of entire voyages abandoned when currents shifted unexpectedly, saving fleets from vanishing into becalmed seas. The Phoenicians, too, watched for changes. A weakening of the Mediterranean's westward flow could mean poor harvests in Carthage months later, as it signaled reduced rainfall over North Africa. These weren't superstitions, they were sophisticated ecological forecasts. A Viking saga describes how a sudden warming of the North Atlantic current, now called the Gulf Stream's fingerprint, preceded a decade of violent storms, forcing Norse settlements in Greenland to alter their trade routes. Modern ice core studies confirm these temperature spikes occurred exactly when the sagas recorded them. The real brilliance lay in how cultures adapted. Pacific Islanders developed current charts woven from palm fibers, showing how to hop between eddies like stepping stones. The Maori of New Zealand timed their migrations to the Tasman Current's seasonal strengthening, riding it south to richer fishing grounds. Even the monsoon-driven how trade of the Indian Ocean relied on current knowledge, sailing northeast in summer when winds and flows aligned, then reversing course in winter. This wasn't just navigation, it was a dance with the ocean's heartbeat, but the current's greatest lesson was their fragility. When the Kuroshio shifted during medieval warm periods, Japanese fishermen recorded collapses in sardine catches that lasted centuries. The Phoenician Empire's decline coincided with a slowdown in Mediterranean circulation, disrupting their trade networks. Today, as we face our own climate upheavals, these ancient observations take on new urgency. The ocean's highways are rewriting themselves once more, and the past whispers a warning. Civilizations that ignore the current's language do so at their peril. Albatrosses weren't just fellow travelers, they were living compasses. Ancient Polynesian navigators knew these majestic birds flew out to sea at dawn to hunt, returning to land by dusk, creating invisible highways in the sky. By tracking their flight paths, sailors could pinpoint islands far beyond the horizon. But the true masters of bio-navigation were the Maori, who followed the annual migrations of humpback whales, not just as prey, but as guides. The whales' routes marked safe passages through treacherous waters, their presence revealing hidden seamounts and underwater canyons where currents converged. This wasn't just observation, it was a partnership where humans and animals co-created maps written in movement and instinct. Seabirds transformed the open ocean into a grid of clues. Pacific Islanders recognized that certain species, like the white tern, never ventured more than 30 miles from land. Spotting one meant safety was near, while frigatebirds, which could range hundreds of miles, indicated distant shores. But the real genius lay in reading their behavior. Birds flying high and purposefully often headed toward land, while those circling erratically might be fishing over submerged reefs. Even their sounds carried meaning. The sudden silence of a seabird colony could warn of an approaching typhoon long before clouds darkened the horizon. Marine life offered its own language. Sharks diving to deeper waters signaled dropping barometric pressure, a storm's first whisper. Dolphins herding fish into tight balls often did so ahead of temperature shifts that preceded squalls. The Rapa Nui of Easter Island even listened to coconut crabs, noticing how their frantic climbing to higher ground foreshadowed tsunamis. Modern research confirms these crabs detect infinitesimal changes in atmospheric pressure, acting as living barometers. What ancient navigators understood was that animals don't just react to weather. They anticipate it, their bodies fine-tuned to environmental shifts our instruments still struggle to measure. This interspecies knowledge wasn't passive, it required deep attunement. Viking sagas describe navigators tossing scraps to gulls, not just as offerings but as experiments. If birds refused food, it hinted at inland storms driving prey away. Polynesian healers studied the fat content of caught fish. Lean catches meant distant food chain disruptions, often signaling broader ecological shifts. These weren't superstitions but sophisticated data streams, where every animal interaction carried layers of meaning. Today, as coral reefs bleach and fisheries collapse, these ancient practices hold urgent lessons. When albatross populations plummeted in the North Pacific, modern scientists realized it wasn't just an ecological loss. It erased a millennia-old navigation marker for indigenous Alutiiq hunters. Around the Maldives, fishermen now struggle to predict monsoons because overfishing has silenced the reef fish whose spawning once heralded seasonal rains. The irony is stark. Just as climate change makes traditional forecasting vital, industrial exploitation is severing the very connections that made it possible. Yet hope emerges where old wisdom meets new science. In Alaska, Yupik elders partner with biologists to document how seal behavior predicts ice melt patterns more accurately than satellite models. In the Caribbean, fishermen revived the ancient practice of tracking spawning trigger fish. Their movements now help forecast hurricanes months in advance. These aren't nostalgic gestures but hybrid systems, merging ancestral knowledge with conservation technology. The animals haven't stopped speaking, we've forgotten how to listen. And in a world where satellites fail during solar storms and GPS jamming threatens modern navigation, relearning bionavigation might be more than just cultural preservation. It could be a matter of survival. The next time you see birds swirling before a storm or ants marching to higher ground, remember, you're witnessing a language far older than written words. Ancient navigators understood that nature's signals aren't metaphors but a living library where every creature holds a page. Our ancestors sailed oceans guided by this wisdom, not because they lacked technology, but because they possessed something deeper, the humility to learn from masters who'd been reading the Earth's rhythms for millions of years before humans ever took to the sea. Lunar cycles didn't just tug at the ocean's surface, they pulled at the very fabric of ancient civilizations. Along the Welsh coastline, fishermen consulted notched stones known as tide stones, where centuries of observations had been etched into rock. At a glance, these markings revealed how high the tide would crest during specific moon phases, turning geology into a lunar calendar. But this wisdom wasn't unique to Wales. Half a world away, the Babylonians compiled meticulous clay tablet records showing how the moon's position influenced not just tides, but river floods in Mesopotamia. Their predictions were so precise, they could forecast the Euphrates' rise within a hand's breadth, allowing farmers to plant crops with near-perfect timing. What's staggering is how these lunar insights became instruments of war and conquest. When Genghis Khan's armies planned their siege of the Khwarezmian Empire, they timed their attacks to coincide with the new moon, not for superstition but strategy. Under the cloak of a moonless night, their cavalry could cross shallow rivers at low tide, catching enemies off guard. Similarly, Chinese naval commanders during the Tang dynasty scheduled coastal assaults around spring tides, when the moon's pull created extreme highs and lows that could strand enemy fleets on suddenly exposed mudflats. The moon wasn't just a celestial guide, it was the ultimate military advisor, its rhythms dictating the outcome of battles. Temples, too, bowed to lunar logic. At India's Chandrabhaga beach, the ancient Konark Sun Temple was designed so that during the equinoxes, moonlight would strike its central shrine at the exact moment high tide peaked, a celestial choreography blending architecture, astronomy, and hydrodynamics. The Maya took this further, constructing their coastal city of Chelum so that during the full moon, waves would crash against its cliffs with such force they created booming echoes, turning the ocean into a ceremonial drum. These weren't just pretty alignments, they were profound acknowledgments that human endeavors thrived when synchronized with cosmic cycles. The real breakthrough came when cultures connected lunar phases to broader ecological patterns. Polynesian navigators noticed that certain tides triggered coral spawning events, which in turn attracted massive schools of fish. By tracking the moon, they could predict not just when to sail, but when to harvest. Norse farmers in Iceland observed that winter frosts bit hardest during waning moons, guiding them to store extra fodder for livestock. Even today, modern studies confirm these patterns. Lunar tides influence groundwater levels, which ancient cultures from the Hopi to the Han had long exploited for irrigation timing. Perhaps the most haunting lunar legacy lies in its warnings. Aboriginal Australians recorded stories of time before tides, when the moon didn't exist and the oceans lay stagnant. Their oral histories describe how the moon's arrival brought not just tides, but cyclical floods, knowledge that allowed coastal tribes to migrate inland during danger periods. Similarly, Icelandic sagas tell of moon winters, when unusually high tides during lunar perigee, the moon's closest approach to Earth coincided with brutal cold snaps. Ice core data now shows these events matched real climatic shifts, proving that ancient observers weren't just myth-making, they were preserving vital survival data across generations. This lunar literacy challenges our modern division between science and intuition. These cultures didn't just track the moon, they conversed with it, recognizing that its silver glow held the keys to everything from full bellies to battlefield victories. In an age where most of us barely notice moon phases beyond their beauty, their legacy whispers a radical idea. That time isn't just something we measure, but a force we navigate by, as tangible as any compass or chart. Solar eclipses didn't just darken the sky, they rewrote history. When day suddenly turned to night over the battlefield between the Lydians and Medes in 585 BCE, warriors on both sides dropped their weapons in terror, interpreting the event as a divine command to cease fighting. This wasn't mere superstition. The eclipse had been predicted by Thales of Miletus, marking one of the first recorded instances where celestial knowledge directly altered human conflict. But while the Greeks saw eclipses as calculable phenomena, other cultures wove them into the very foundations of power. Chinese emperors called them the mandate of heaven's clockwork, where a poorly predicted eclipse could topple dynasties. Astronomers who failed to forecast one often faced execution, their observatories becoming instruments of political control as much as scientific inquiry. The Chacones of the American Southwest took prediction to an artistic extreme. At Chaco Canyon, spiral petroglyphs etched into sandstone cliffs functioned as celestial calendars. When sunlight pierced specific cracks in the rock during solstices, dagger-shaped beams would bisect these spirals, but during eclipses, the patterns transformed. Modern researchers discovered that these carvings mapped 18-and-a-half-year eclipse cycles with startling precision, a rhythm now known as the Saros cycle. What's remarkable is how they achieved this without written records or metal tools, using only stone and patient observation across generations. Their calculator wasn't a device but the landscape itself, turning entire canyon walls into a monumental astronomical instrument. Then there's the Antikythera mechanism, recovered from a 2,000-year-old shipwreck near Crete. This bronze wonder, often called the world's first analog computer, contained over 30 interlocking gears that could predict lunar and solar eclipses decades in advance. But its true genius lay in how it mirrored ancient cosmology. The device didn't just calculate dates, it displayed eclipses as celestial omens, with inscriptions warning of potential outcomes based on Babylonian astrological traditions. A solar eclipse in the constellation of Scorpio might portend a king's downfall, while one in Virgo could signal bountiful harvests. For its creators, the mechanical and the mystical weren't opposites, they were partners in deciphering the universe's patterns. Eclipse prediction became the ultimate power play across civilizations. The Babylonians guarded their eclipse tables like state secrets, using them to manipulate treaties by foretelling celestial events during negotiations. In Vietnam, the ruling Lai dynasty claimed descent from a dragon who swallowed the sun, staging elaborate ceremonies where emperors would rescue the moon during lunar eclipses to demonstrate their divine connection. Even today, echoes of this awe persist. NASA engineers report that during total eclipses, wildlife still falls silent as if obeying some ancient programming, a reminder that these events tap into instincts far older than recorded history. Science may have stripped eclipses of their supernatural terror, but not their wonder. Modern calculations can pinpoint future eclipses down to the second, yet crowds still gasp when the sun's corona flares into view. Perhaps that's the real lesson of these ancient tools. They weren't just about prediction, but about preserving our capacity for astonishment under the shadow of the unknown. The Chacon petroglyphs and Antikythera gears whisper across centuries that understanding a phenomenon doesn't diminish its power. It simply changes the language we use to describe the magic. Wind patterns didn't just fill sails, they built empires. Take the Phoenicians, whose cedar ships dominated Mediterranean trade by riding the Etesian winds like clockwork every summer. These predictable northerlies became their secret weapon, allowing them to sail from Tyre to Carthage in weeks while rivals struggled against headwinds. But their real genius lay in decoding secondary patterns, how morning land breezes near Cyprus could help ships slip into harbors undetected, or how sudden gusts around Sicily signaled approaching storms. This wasn't just navigation, it was wind whispering, turning atmospheric physics into commercial advantage. Their monopoly on purple dye and Lebanese timber wasn't just about resources, it was about owning the knowledge of when and how to move them. Across the Indian Ocean, the Swahili coast's golden age was literally blown into existence by the monsoon system. From Mogadishu to Kilwa, cities thrived because merchants knew the Kaskazi winds would carry them south from Arabia between December and March, while the QC winds would push them home April through September. But here's what history books often miss. These winds didn't just enable trade, they dictated its very rhythm. Sail too early on the Kaskazi, and you'd miss the annual coral harvest in Zanzibar. Leave too late on the QC, and monsoon-fed farms in Oman would already have shipped their date harvest. The winds didn't just transport goods, they synchronized entire economies across continents. Yet wind mastery had its perils. In 1206, Genghis Khan learned this brutally when his invasion fleet, poised to strike Japan, was annihilated by what chroniclers called the kamikaze, or divine wind. Modern meteorology reveals this was no act of gods but a typhoon born from late-season monsoon turbulence. The Khan's navigators, experts in continental steppe winds, had miscalculated Pacific patterns. That single storm didn't just sink ships, it redirected Mongol expansion permanently, sparing Southeast Asia from the hordes that overran Eurasia. Winds didn't just build empires, they broke them. The most sophisticated wind readers were perhaps the Bugis sailors of Indonesia, whose Lontara manuscripts mapped over 30 distinct wind types. Their Mawa's wind indicated safe passage through the Makassar Strait, while the Barat warned of coming squalls that could swamp a prahu in minutes. But their real innovation was connecting winds to celestial events, knowing that when the Pleiades rose with the east monsoon, it was time to harvest Trepang before the winds shifted. This created a feedback loop where astronomy, meteorology, and economics intertwined. Today's satellite forecasts might seem to make wind lore obsolete, but ancient lessons still resonate. Modern container ships still ride the Agulhas current's tailwinds to save fuel, while renewable energy companies study medieval wind maps to site turbines. The difference is stark. Where we see wind as a resource to exploit, ancient cultures saw it as a dialogue partner, capricious, powerful, demanding respect. Maybe that's why the old wind rose compasses depicted directions as deities, not degrees. They understood something we've forgotten, that the air itself has memory, and those who listen carefully can hear empires whispering in the breeze. The ocean's surface wasn't the only map ancient navigators could read. They charted their course through sound, turning the very air and water into instruments. Viking sagas tell of crews shouting into the fog, timing how long it took for echoes to rebound off distant cliffs. A 2-second delay might mean land was 300 meters away, a calculation so precise it could guide longships through fjords even in pitch darkness. But this wasn't just about physics. It was about training the ear to distinguish between the hollow knock of sound reflecting off ice versus the deeper boom off solid rock, a skill that meant the difference between safe harbor and a splintered hull. Half a world away, Polynesian navigators developed an even subtler art, listening to the sea's resonance. As waves collide with submerged reefs, they create distinct vibration patterns that travel for miles. By pressing their ears against the hull or dipping a paddle into the water, Wayfinders could detect these frequencies, interpreting them like musical notes. A low, rhythmic pulse might indicate a coral barrier 20 kilometers ahead, while a sharp, irregular chatter signaled treacherous volcanic outcrops. Modern hydrophone studies confirm these patterns exist, proving what oral traditions have long claimed, that the ocean doesn't just move, it sings. The Guanches of the Canary Islands took auditory navigation to another level entirely. In their labyrinthine lava caves, they perfected a whistled language called Silbo-Gamaro that could carry messages over 15 kilometers. But its genius lay in adaptation. Different pitches bounced off specific rock formations, allowing whistlers to see their surroundings through sound. A high trill might echo differently off a stalactite-filled chamber versus a smooth tunnel, creating an acoustic map as detailed as any visual one. Today, this technique inspires modern sonar systems, yet the Guanches version required no technology, just intimate knowledge of how sound sculpts space. What united these cultures was their holistic sensory awareness. Maori navigators could identify nearby land by tasting the air. Certain seabirds' presence lent a faint saltiness, while volcanic soil carried a metallic tang. Inuit hunters still read snow's squeak underfoot to gauge temperature. A high-pitched crunch means -40 degrees, dangerous for travel. These weren't party tricks but survival skills, honed through generations of deep observation. In a storm, when stars and landmarks vanished, sound became the compass. Taste the weather vane, touch the chart. The tragedy is how much we've unlearned. Modern GPS relies on a single sense sight, flattening the rich dimensionality ancient navigators embraced. But echoes of their wisdom persist. Fishermen in Brittany still read waves by sound to locate mussel beds, while Tibetan monks use throat singing to measure cave depths during pilgrimages. Scientists now study these techniques to improve underwater robotics, proving that the old ways aren't obsolete, just overlooked. Perhaps the most haunting example comes from the Marshall Islands, where elders recall a lost practice called dribbling. Navigators would pour water onto the deck and listen as it pooled, using the sound to detect subtle shifts in the ship's balance caused by distant currents. No instrument could measure this. It required a lifetime of attuning to the sea's whispers. In our age of satellite pings and digital displays, we've gained precision but sacrificed a deeper language, one where every ripple, every echo, every taste on the wind told a story. The ocean still murmurs its secrets, but fewer and fewer know how to listen. Societal collapse rarely arrives with a single cataclysmic event. It creeps in through forgotten knowledge. When the classic Maya abandoned their soaring limestone cities around 900 CE, they didn't just leave behind empty temples. They walked away from the most sophisticated celestial calendars the ancient world had ever seen. Devices that had predicted droughts for centuries by tracking Venus's erratic orbit. These weren't just timekeepers, they were ecological early warning systems. The Dresden Codex's Venus tables had once allowed Mayan rulers to stagger crop plantings, avoiding famine when dry spells came. But as political chaos grew, the astronomer priests who interpreted these cycles were sidelined. By the time the last scribe etched his final glyph, the knowledge of how to read the sky for coming disasters had already faded. The result, cities that had thrived for 600 years collapsed within decades, their reservoirs dry and fields barren, not because the rains failed, but because no one remembered how to prepare for their absence. Half a world away, a different kind of forgetting doomed the Greenland Norse. Their sagas brim with tales of heroic voyages, yet they stubbornly dismissed the Inuit techniques that could have saved them. While Norse ships ran aground on misjudged ice floes, the Thule people glided across the same waters in sealskin kayaks, reading the ice's texture and color like a map. Dark streaks meant thin ice to avoid, milky patches signaled safe thickness. The Norse, clinging to their European traditions, never adopted these methods even as winters grew harsher. When the Little Ice Age hit in the 14th century, their settlements starved, surrounded by seas teeming with seals they didn't know how to hunt and ice they couldn't navigate. The last written record from Greenland's western settlement is a wedding contract from 1408, a brittle parchment oblivious to the fact that its signers were among the final survivors of a culture that refused to learn. These weren't isolated tragedies. The Rapa Nui of Easter Island toppled their own ecosystem by abandoning celestial navigation that once guided sustainable fishing. The ancestral pueblones of Choco Canyon, masters of solstice alignments, may have overextended their water systems when lunar cycle records were neglected. In every case, collapse followed not just environmental change, but the loss of tools to interpret it. The real catastrophe wasn't drought or ice, it was amnesia. Fast forward to today and the parallels sting. The Marshall Islands stick charts, which mapped ocean swells with palm ribs and shells, are now museum pieces as satellite navigation replaces traditional wayfinding. But when Typhoon Mangkhut disabled GPS across Micronesia in 2018, fishermen raised on digital maps couldn't read the wave patterns their grandparents would have recognized instantly. Meanwhile, Greenland's thawing ice sheets are revealing something haunting: perfectly preserved Viking sledges and hunting gear buried for centuries under snow. The artifacts are pristine, but the knowledge to use them is gone, just as we're facing climate shifts that demand precisely that kind of adaptive wisdom. The lesson etched into these ruins isn't about nostalgia for the past, it's about the price of disconnection. Ancient navigation systems were more than tools, they were living libraries of climate data, refined through generations of observation. When Polynesians avoided voyages during certain lunar phases, they weren't following superstition, they were heeding centuries of storm records encoded in chants. When Inuit hunters checked the wind's direction before setting out, they were consulting an oral database of seasonal patterns stretching back further than written history. These cultures didn't just survive, they thrived by treating the environment as a language to be studied, not an obstacle to be conquered. Now the Earth is speaking again through melting glaciers, shifting jet streams, intensifying storms, and we're at risk of repeating history's gravest mistake, ignoring the messengers. The Maya's Venus tables and the Inuits' ice law weren't just clever tricks, they were lifelines forged through patience and attention. As we face our own era of upheaval, their ghostly whispers carry an urgent question. Will we relearn how to listen, or will we too become cautionary tales in some future civilization's textbook? The difference this time is we have their ruins as proof that societies don't fail when the climate changes, but when they forget how to read its signs. Polynesian legends whisper of Hina, the moon goddess who taught celestial navigation to her daughters, not as myth, but as living memory. Across the Pacific, women known as Kaikuahain held sacred star chants in their bones, memorizing hundreds of rising and setting positions that guided double-hulled canoes across thousands of miles. These weren't passive passengers, they were master navigators who could feel land long before it appeared, interpreting the flight patterns of noddy birds or the sudden sweetness in the air as signs of approaching atolls. In Tonga, grandmothers trained girls to weave palm frond maps showing wave refraction patterns around islands, knowledge so vital it was considered too precious to entrust solely to men who might be lost at sea. The Norse had their own counterparts. The saga of Eric the Red describes Freydis Eiríksdóttir in not just accompanying voyages to Vinland, but taking command when storms disoriented male crews. Shield maidens like her were said to read the vindsticky, those ethereal wind arrows in the sky, with uncanny precision, steering ships through fog by interpreting subtle changes in wave slap against the hull. What these stories share is a quiet truth. Women's navigation often relied on senses beyond brute strength. Where men might muscle through rough seas, women like the Sami Nowidi of Scandinavia listened to the creak of sea ice, predicting fractures by sound alone, a skill that saved entire migratory groups when spring thaw came early. On the Pacific Northwest coast, Haida matriarchs controlled the lunar tide charts that dictated when to harvest clams or launch canoes. Their daughters learned to read the talking sticks, carved markers, showing how extreme tides would be each season based on decades of observation. This wasn't domestic knowledge, it was high-stakes science. A miscalculation meant being trapped in narrow inlets when 30-foot tidal surges roared in. Among the Chumash of California, women pharmacologists doubled as navigators, brewing tidal prediction potions from wild tobacco that induced visions of coming swell patterns. A practice modern researchers suspect leveraged the plant's psychoactive properties to enhance spatial memory. The real distortion happens when we call these roles exceptions rather than systems. Micronesian folklore speaks of the weavers of the waves, women who tied intricate knots representing ocean currents into fishing nets, creating tactile maps passed down through generations. In pre-colonial Hawaii, the hula wasn't just dance, it was a navigational database. Women performers encoded star paths and storm signs in hip movements and hand gestures, turning their bodies into living libraries of wayfinding knowledge. When Western missionaries banned the hula, they didn't just erase art, they deleted centuries of hydrodynamic data. Even pregnancy became a tool of navigation. Maori traditions tell of Wahine Tohunga, who could sense underwater currents through the heightened proprioception of their changing bodies, using the fetus's movements as a biological inclinometer to balance canoes. The Cherokee recorded similar practices, where expectant mothers interpreted morning sickness patterns as indicators of coming weather shifts, a phenomenon modern medicine now links to hormonal sensitivity to barometric pressure changes. These weren't mystical powers, they were honed adaptations, the result of cultures that recognized feminine physiology as another valid way of knowing the world. The sea has no gender, and neither did survival. From the Breton women who could smell approaching storms in the milk of their cows to the Japanese armored divers who mapped ocean floors by touch during pearl harvests, navigation was always a tapestry of perspectives. Restoring these threads does more than correct history. It reminds us that the greatest voyages were never solo endeavors, but chorus efforts where every voice, every skill, every way of seeing had its place in the grand symphony of not getting lost. The stars didn't just guide ships, they whispered epics. Take the Greek legend of the Argo, its timbers cut from Dodona's prophetic oak, said to groan warnings when reefs lurked ahead. Modern archaeologists have found Bronze Age shipwrecks with oak pegs precisely where Homer described the talking joints, suggesting these myths preserved real nautical engineering, the creak of wood under stress signaling danger long before sonar. Across the Pacific, Maori elders still chant the story of Toma Rareti, whose celestial canoe became the Milky Way. Every bend in that starry river corresponds to actual current lines between Tahiti and New Zealand, turning mythology into a sung atlas. These weren't bedtime stories, they were geolocating ballads where heroes' journeys doubled as sailing directions. Even monsters held navigational secrets. Scandinavian sailors avoided the maelstrom called Virgilmere, not just from fear, but because the eddy's whirlpool behavior changed predictably with lunar tides knowledge embedded in tales of the serpent Jörmungandr biting its tail. The Inuit spoke of Sedna, the sea goddess whose severed fingers became seals. Her anger caused storms, but her benevolence brought calm waters when hunters observed taboos about lunar cycles. What outsiders dismissed as superstition was actually ecological law coded in allegory. Break the rules and the environment retaliates. The brilliance of these systems lay in their resilience. Written charts burned or faded, but everyone remembers a good story. Polynesian star chants could stretch for hours, encoding swell patterns in rhythmic couplets. Viking runestones often included simple rhymes about wind directions. East breeze brings bees to the hive, west warns of storms alive, ensuring even children retained critical knowledge. When the Library of Alexandria burned, it took generations of Mediterranean sailing lore with it, but oral traditions like the Micronesian wave pilots, who memorized 24 distinct ocean rhythms through song, survived colonialism's erasure because stories live in bones and breath. Perhaps the most profound lesson lies in how these cultures framed their relationship to the cosmos. Where modern maps place humans at the center, ancient myths position people as participants. The Navajo Diné Bahane creation story doesn't just describe how first man arranged the stars, it explains why certain constellations only appear seasonally, linking celestial movements to sheep grazing cycles. Aboriginal songlines transform the entire Australian continent into a musical score, where every hill and waterhole is a note in an epic that's both map and moral code. To follow these stories wasn't just navigation, it was reverence, an acknowledgement that every journey ripples through a living universe. Today, as light pollution obscures the stars and GPS replaces intuition, these myths take on new urgency. They remind us that wayfinding was never just about coordinates, it was about connection, about reading the world as a story where we're both characters and co-authors. The next time you look up at Orion's belt, remember, you're not just seeing stars, you're glimpsing the oldest library on Earth, its shelves lined with tales that once steered entire civilizations home. The Marshall Islanders' stick charts weren't just maps, they were living conversations between generations. Woven from curved palm ribs and cowrie shells, these intricate models didn't depict coastlines or compass points. Instead, they mapped the ocean's pulse, showing how swells bent around distant atolls or converged into invisible highways between islands. A shell wasn't just an island marker. Its position revealed how waves would refract as you approached, turning the chart into a tactile guide for reading the sea's ever-shifting language. Navigators didn't just consult these charts, they memorized them through touch, internalizing patterns that GPS coordinates could never capture. When European explorers first encountered these primitive maps in the 19th century, they dismissed them as curiosities. Only later did hydrographers realize their astonishing accuracy, discovering that the same wave interference patterns existed exactly where the shells and sticks predicted. Meanwhile, halfway across the world, Mediterranean sailors were crafting their own revolution with Portolan charts. These weren't the symbolic, fantastical maps of medieval Europe. They were ruthlessly practical, drawn from centuries of accumulated sailing logs. Using compass roses and room lines, they plotted harbors and hazards with precision that still astonishes modern cartographers. A 13th century Portolan of the Black Sea, for example, matches satellite imagery so closely that historians suspect they were drafted using systematic surveys. But here's the catch: Portolans didn't just record space, they encoded time. Tiny notations marked seasonal currents, wind shifts, even the best months to anchor in specific bays. A skilled sailor could unfold a single parchment and access generations of hard-won experience, yet something profound changed when knowledge moved from memory to parchment. Oral traditions adapted like water. Polynesian navigators could update their mental maps after a single voyage, adding new swell patterns to their chants. But ink froze wisdom in place. A Portland chart from 1420 wouldn't reflect a harbor silted up by a storm in 1425. The very permanence that made written maps powerful also made them brittle. Greek pilots who'd once memorized the whistle of wind through Aegean straits now stared at fixed lines on vellum, losing the ability to hear approaching weather in the rigging's creak. This shift reshaped more than navigation, it altered human cognition itself. Oral cultures thought in cycles and relationships, where every star was connected to seasons, tides, and stories. Written maps imposed grids and hierarchies, dividing the world into controllable segments. When Tupaia, a Tahitian priest navigator, sketched a map for Captain Cook in 1769, the British crew couldn't comprehend its radial design, islands positioned not by latitude but by their significance in Polynesian voyaging traditions. To Tupaia, Rarotonga wasn't just a dot, it was a node in a web of ancestral routes and monsoon winds. Today, we're left with echoes of both worlds. Modern sailors still trace routes on digital charts, but the Marshall Islands' last traditional navigators can sense a typhoon's approach by the way their canoe vibrates in calm seas. Portland's room lines evolved into the GPS grid, yet Inuit elders navigate whiteouts by listening to snow crunch underfoot. The oldest maps remind us that true knowledge isn't just about accuracy, it's about adaptability, about reading the world as a dynamic story rather than a static snapshot. Perhaps that's the real lesson etched into those palm ribs and parchment, that getting lost isn't just a failure of technology, but a forgetting of how to listen. The compass needle didn't just point north, it pointed toward power. When Portuguese caravels first rounded Africa's Cape of Good Hope, their astrolabes and quadrant weren't merely tools, they were instruments of empire as vital as cannons or gold. The British Admiralty knew this too well. By the 1700s, their fleet's mastery of the marine chronometer, a clock so precise it could determine longitude at sea, transformed oceans into British highways. Suddenly, the Royal Navy could strike anywhere, anytime, with terrifying precision. Spanish galleons guarded their Carrera de Indias routes like state secrets, executing any foreign sailor caught with maps of the Caribbean. But this wasn't just about keeping rivals lost, it was about controlling the very flow of wealth, turning navigation into a monopoly as lucrative as any silver mine. Yet for every empire hoarding knowledge, there were those who weaponized silence. In the Marshall Islands, wave pilots deliberately misled European ships by sharing false star charts, steering them into treacherous reefs. The Maori of New Zealand hid their Paunamu jade routes within sacred songs, ensuring colonial traders couldn't plunder their most prized resource. And when the Dutch demanded Bugis sailors hand over their wind maps of the Indonesian archipelago, the navigators responded with maps so accurate they were useless, omitting the monsoon's subtle cues that only decades of lived experience could decode. These weren't acts of defiance, they were acts of survival, proving that the strongest fortress wasn't made of stone but of withheld knowledge. The irony is stark. While Europe's empires saw navigation as a means to conquer, the cultures they encountered understood it as a covenant with the natural world. The British Admiralty's chronometers reduced the sea to a grid of coordinates, but Polynesian navigators still spoke of the ocean as a living entity, its currents and creatures collaborators rather than obstacles. The Spanish measured the New World in leagues and pesos, yet the Maya they displaced had tracked Venus for centuries, not to exploit, but to align their society with cosmic rhythms. Two worldviews collided, one seeking to possess the Earth, the other to belong to it. This clash reshaped history in ways we're still unraveling. When the British East India Company standardized nautical charts in the 1800s, they didn't just streamline trade, they erased entire oral traditions. Malay pilots who'd memorized the Andaman Sea's shifting sandbars found their expertise obsolete overnight, replaced by printed maps that couldn't account for monsoonal changes. The very tools that promised to democratize navigation instead concentrated power in the hands of those who controlled the presses, and yet whispers of resistance lingered. In the Azores, fishermen still navigate by the luces dos pescadores, mysterious lights on the horizon that science can't explain but locals swear mark hidden seamounts. In Labrador, Inuit hunters ignore GPS when seal hunting, trusting instead the ancestral practice of reading snowdrift shapes for wind direction, a skill that saved entire villages during a 2018 satellite outage. What's haunting is how these stories mirror our present. Today's digital maps promise omniscience, yet they're owned by corporations that monetize every click and turn. The same satellites that guide rescue teams also steer drone strikes. The compass that once built empires now lives in our pockets, tracking us even as it directs us. Perhaps that's the real lesson of this history, that no navigational tool is ever neutral. It carries the imprint of those who made it and the weight of those who resisted. The question isn't just how we find our way, it's who gets to draw the map and who's left off it entirely. High above the beaches of Hawaii's Kohala coast, weathered lava rock tells a story in stone petroglyphs of towering waves swallowing stick-figure humans, carved centuries before the first seismograph. These aren't just art, they're data. When elders from the Payukohola Heiau temple recite chants describing these same tsunami events, their words match geological records of underwater landslides from the year 1600. Half a world away, Inuit hunters still sing about the time when the ice cried, describing glacial calving events that ice core samples now confirm occurred during medieval warming periods. What modern scientists need ice drills and sediment cores to uncover, these cultures preserved in story and symbol, transforming oral tradition into an unbroken climate archive spanning millennia. The real revelation lies in how these records were kept. Unlike modern climate models that isolate variables like temperature or CO2, ancient systems tracked connections. Polynesian navigators knew that when the star Ki Ale o Kona Iki rose later than usual, it signaled shifts in trade winds that would eventually trigger El Niño droughts, a correlation modern meteorology only confirmed in the 1980s. Inuit elders taught that thinning sea ice changed polar bear behavior years before it altered hunting seasons, treating animal movements as early warning signs rather than isolated events. These cultures didn't just observe changes, they mapped relationships, building mental models where celestial patterns, animal migrations, and ocean currents were threads in the same tapestry. Consider the Aboriginal Australian songlines, which encode climate knowledge in melodies. Certain notes correspond to flowering cycles of desert peas. When sung out of season, they warned of coming droughts. The Warlpiri people's songs describe groundwater locations so precisely that during Australia's 2019 bushfires, their ancient lyrics guided firefighters to hidden springs when modern maps failed. This isn't coincidence, it's the result of generations fine-tuning survival algorithms in musical form, where every verse contains layers of ecological insight. Today's climate scientists are racing to decode these patterns before they vanish. When researchers compared Marshallese wave pilots' oral histories with satellite data, they discovered the navigators had been tracking Pacific decadal oscillation shifts, a climate cycle modern instruments only identified in 1997. The Maori lunar calendar, once dismissed as folklore, is now used by New Zealand wineries to predict harvest seasons disrupted by climate change. Even the Vikings' fog-eating trees observation that certain mosses thrive before storms has been validated by biologists studying humidity-sensitive plants as natural barometers. The urgent lesson isn't just that ancient cultures predicted weather, it's that they viewed disruption as a language, where we see rising sea levels as meters and millimeters. Pacific Islanders read them through the lens of myth. Their story of the octopus goddess Lupe shrinking back into the deep mirrors real-world octopus migrations to cooler waters, a narrative that encodes both loss and adaptation. The Greenland Inuit's tales of Sedna's anger, where the sea goddess withholds seals when humans break taboos. Parallel modern ecosystem collapses from overhunting. These stories weren't just explanations, they were ethical frameworks, teaching that environmental abuse carries consequences. As permafrost thaws and coral bleaches, these ancient warning systems are gaining terrifying relevance. The same Hawaiian petroglyphs that recorded tsunamis also depict Hianalu, legendary waves that came not from earthquakes but from collapsing cliffs, a hazard rising seas are recreating today along Alaska's glaciers. Inuit elders now watch their 1,000-year-old ice melt predictions unfold in real time, with polar villages relocating just as oral histories advised. The past isn't just whispering to us, it's shouting through the cracks in our collapsing assumptions. The real question isn't whether we'll listen, but whether we'll still recognize the signs when the water reaches our doorsteps. To the Maori master carvers who shaped waka from towering kori trees, every ad stroke was more than construction, it was conversation. Each canoe carried not just passengers, but the literal embodiment of ancestors, their names and stories etched into the prow. The waka toa, or war canoe, wasn't merely a vessel. It was a floating genealogy, its hull lines mirroring the tribal tattoos of the warriors who manned it. When British colonists banned these carvings in the 19th century, they weren't just suppressing transportation, they were severing a living chain of memory that connected generations to the sea. Today, as Maori communities rebuild waka using traditional methods, they're not reviving boats, they're resuscitating a language of wood and water that whispers how their people first navigated the Pacific. Now picture the Inuit kayak, its sealskin hull stretched taut over a driftwood frame. Where the waka celebrated lineage, the kayak encoded Arctic survival in every stitch. The slight curve of its bow wasn't just aerodynamic, it mimicked the shape of breaking waves, allowing hunters to ride swells silently toward seals. The cockpit's rim, often lined with polar bear fur, created a watertight seal with the paddler's coat, a technique so effective modern dry suits still imitate it. But the real genius lay in its customization. No two kayaks were alike, each tailored to its owner's body and hunting style through a ritual of measurement using the paddler's own hands and fingers as calipers. When missionaries destroyed these pagan vessels, they weren't eliminating a tool. They were erasing a biomechanical masterpiece refined over millennia. The contrast between these designs reveals a profound truth. Navigation tools were ecological fingerprints. Polynesian outriggers spread weight for tropical lagoons, while Viking longships rode high for fjord ice. The Maoris' crescent-shaped paddles harnessed the Pacific's rhythmic swells, just as Inuit paddle blades were squared for quick strokes in choppy Arctic waters. These weren't accidents of geography but dialogues with place, the ocean shaping the tool shaping the culture. When the Maori of the Chatham Islands abandoned ocean voyaging after centuries of isolation, their canoes shrank from 30-meter seagoing vessels to small river craft in just a few generations, a visible shrinking of worldview as literal as it was metaphorical. What's at stake in their revival isn't just preserving artifacts, but safeguarding entire philosophies. The Tlingit of Alaska say a well-built canoe doesn't cut through waves, it introduces itself properly, asking permission to pass. Hawaiian navigators still speak of talking to the ocean before voyages, not as ceremony but as practical ecology, attuning themselves to subtle changes in swell patterns. This reciprocity stands in stark contrast to modern navigation's extractive mindset, where GPS satellites orbit oblivious to the waters they map. The difference is spiritual as much as technical. One approach sees the sea as family, the other as coordinates. Nowhere is this cultural reawakening more urgent than in the Marshall Islands, where elders are teaching youth to read wave patterns again, not because they've lost GPS, but because they've realized what else was lost with it. During a 2018 typhoon that knocked out satellite signals, it was the grandson of a traditional navigator who guided his community to safety by reading ocean swells his phone couldn't perceive. In New Zealand, Waka building schools report something unexpected. As Maori youth learn to lash canoes with flax ropes, their test scores in Western science improve simultaneously. It turns out that handling geometry in 3 dimensions, calculating buoyancy, tension, and balance through touch rather than equations, rewires the brain to grasp abstract concepts differently. This renaissance isn't about rejecting modernity but restoring balance. When Inuit hunters today strap GPS units to their kayaks, they're not betraying tradition. They're layering knowledge, using satellites for long-range plotting while trusting ancestral ice reading skills for close navigation. The Maori Waka Aoyua double-hulled canoe Hokulea famously sailed from Hawaii to Tahiti using only traditional methods in 1976, yet its latest voyages carry climate scientists studying ocean microplastics. These tools are becoming bridges, not relics, a proof that the oldest ways of seeing might hold solutions to our newest crises. Perhaps that's the ultimate navigation lesson. Diversity isn't just cultural ornamentation, it's evolutionary advantage. Just as ecosystems thrive through genetic variety, human survival may depend on cognitive biodiversity, on maintaining multiple ways of reading the world. The kayak's silence and the Waka's carvings, the Polynesian star compass and the Viking sunstone, they're all dialects in Earth's survival language. Losing any isn't just losing a tool, it's losing a voice that might have whispered the very warning we need to hear. Modern astrophysicists at NASA, a jet propulsion laboratory, made an astonishing discovery when they analyzed Polynesian star compasses. These ancient wayfinding systems plot celestial paths with mathematical precision that could guide spacecraft between planets. The same star sequences that led canoes to Tahiti now inform algorithms for interplanetary probes, proving that the Pacific Star highways align eerily well with gravitational corridors in our solar system. Meanwhile, in the Arctic, climate scientists watched in awe as Inuit elders predicted a freak winter storm 3 days before satellite models detected it. Their secret, a centuries-old rhyme about ice thickness. When the young ice sings high, the old ice will soon cry. Turns out, the pitch of freezing seawater really does shift with atmospheric pressure changes, creating an acoustic early warning system modern meteorology had overlooked. Archaeoastronomers wielding laser scanners recently uncovered Stonehenge's hidden genius. Its massive stones don't just mark solstices. They frame the moon's extreme northern and southern positions during tidal surges, creating a 18.6-year tidal predictor carved in Salisbury Plain. Bronze Age engineers essentially built a Neolithic supercomputer for tracking ocean rhythms, proving they understood lunar cycles better than most modern sailors. Even the Mayan El Caracol Observatory, long dismissed as primitive, has been revealed as a precision instrument. Its spiral windows align with Venus's 8-year cycle so precisely they could correct modern ephemeris tables. The most humbling validation comes from materials science. Viking sunstones, once thought mythical, outperform modern polarized lenses in foggy conditions. When researchers tested Icelandic calcite crystals in North Atlantic storms, they found the stones could locate the sun's position through cloud cover within 5 degrees accuracy, matching military-grade technology. Similarly, Aboriginal Australian fire-starting sticks, when studied under electron microscopes, showed intentional grain alignments that maximize friction heat, demonstrating sophisticated understanding of thermodynamics millennia before the Industrial Revolution. This isn't about nostalgia for simpler times. It's about recognizing that the scientific method wore many faces. When Polynesian navigators memorized wave patterns, they were conducting hydrodynamic research. Inuit ice thickness rhymes were peer-reviewed climate models passed down through generations. The distinction we draw between traditional knowledge and real science crumbles under scrutiny. Both begin with observation, develop testable hypotheses, and refine understanding through experimentation. The only difference is whether the lab coats were sealskin or starched cotton. Perhaps the most poignant lesson emerges from disaster response. After the 2004 Indian Ocean tsunami, anthropologists noticed something extraordinary. Indigenous communities from the Andaman Islands to Simeulue suffered minimal casualties. Why? Their oral histories contained precise descriptions of water mountains that arrive after earthquakes, warning them to flee inland when the sea receded. Modern warning systems failed, but stories passed down for 7 generations saved lives. Now, UNESCO Ocean Decade Project actively recruits Pacific elders to help calibrate tsunami sensors, merging millennia-old observations with real-time data streams. The implications ripple far beyond navigation. Medical researchers are studying how Maori plant-based poultices accelerate wound healing, discovering antimicrobial compounds modern science had missed. Engineers examine the earthquake-resistant techniques of Inca stone masonry, finding interlocking shapes that dissipate seismic energy better than steel reinforcements. Even NASA life detection protocols now incorporate Aboriginal techniques for spotting microscopic life in barren landscapes methods, refined over 60,000 years of continent-wide observation. This convergence of ancient and modern isn't just correcting the historical record, it's revealing a deeper truth about human ingenuity, that breakthrough insights often come from seeing the familiar through unfamiliar eyes. When Marshallese wave pilots describe ocean swells as the breathing of the ancestors, they're not speaking metaphorically but hydrodynamically, recognizing patterns our instruments are only beginning to quantify. The real frontier isn't just space or the deep sea, but the vast, uncharted territory between ways of knowing where Polynesian star chants might one day guide ships to Mars, and Inuit ice songs could rewrite climatology textbooks. Lost tools whisper to us through the cracks of history, not with answers, but with tantalizing questions. Take the Chinese south-pointing chariot, a mechanical marvel described in texts from the 3rd century. Unlike a simple magnetic compass, this intricate device supposedly used differential gears, technology Europe wouldn't reinvent for over 1,000 years, to keep a figurine perpetually pointing south no matter how the chariot turned. Yet no physical trace survives. Was it real or just imperial propaganda? The answer may lie buried in some forgotten tomb, waiting to rewrite our understanding of ancient engineering. Equally enigmatic is the Norse sun compass, known only from a single wooden fragment found in Greenland. This crisscrossed disc, etched with cryptic notches, allegedly let Vikings navigate under overcast skies by tracking the sun's shadow. But how modern reconstructions suggest it worked like a primitive sundial, calibrated to the solstices, yet without the complete artifact, we're left guessing. Did it incorporate crystals like the legendary Sunstones? Were their variations lost to rot or fire? Every storm-wrecked longship still undiscovered could hold the key. These gaps in the historical record aren't just empty spaces, they're invitations to wonder. The Antikythera mechanism, salvaged from a shipwreck in 1901, was initially dismissed as a corroded curiosity until X-rays revealed its gear trains predicting planetary positions with Swiss watch precision. Before its discovery, no one dreamed ancient Greeks possessed such technology. What other paradigm-shattering devices might lie beneath the waves or crumble in unopened tombs? A single artifact can overturn centuries of assumptions, like the Inca quipu cords once thought to be mere decoration until researchers realized their knots encoded census data, treaties, even poetry. The sea guards its secrets fiercely. Phoenician navigation manuals, mentioned in Roman texts as essential for Mediterranean trade, have vanished without a trace. Polynesian wave charts, woven from palm fibers, disintegrated in tropical humidity. Even the materials themselves conspire against preservation. Viking sun compasses carved from soft wood, Arab camels strung with perishable hemp, all vulnerable to time's relentless erosion. Each loss isn't just a missing object, it's a severed thread in humanity's collective memory. Yet hope persists in unlikely places. Farmers plowing fields from Denmark to Shaanxi still occasionally unearth strange bronze fragments that could be navigational tools. Divers probing Mediterranean shipwrecks find enigmatic discs that might be tide calculators. The puzzle of history isn't just missing pieces, it's pieces we don't yet recognize as part of the picture. When archaeologists recently scanned a medieval prayer book with multispectral imaging, they discovered erased star charts hidden beneath the text, a palimpsest of celestial knowledge nearly lost to ink-scraping monks. What's at stake isn't just filling museum cases, but reclaiming entire worldviews. That lone Norse sun compass fragment, it hints at a navigation system so intuitive, children might have learned it as easily as we learn traffic lights. The south-pointing chariot's alleged mechanics suggest a conceptual leap, not just using nature's forces but bending them to human will. These weren't just tools, they were manifestations of how cultures saw their place in the cosmos. Every rediscovery isn't just an artifact recovered, it's a bridge to a different way of thinking. So the next time you hear of a fisherman hauling up an odd-shaped stone or a hiker spotting strange etchings on a cliff face, remember, history isn't a locked book, but a manuscript with pages still being written. Somewhere in the world's attics and ocean trenches, the next Antikythera mechanism waits, not just to surprise us, but to humble us with how much we still don't know. Navigation in the digital age runs on borrowed wisdom. Those glowing blue GPS lines tracing highways across our screens, they're descendants of Polynesian wave pilots' mental maps, just as satellite constellations mirror the star paths carved into Marshallese stick charts. The algorithms calculating your fastest route home owe their logic to the same pattern recognition that let Inuit hunters predict blizzards from snowdrift shapes. But here's the paradox: we've reached the pinnacle of navigational technology by recreating ancient knowledge, while systematically forgetting how to use it ourselves. Modern pilots joke about children of the magenta line, who can't fly without autopilot guidance, just as sailors stare helplessly at blank radar screens when satellites fail. We carry the world's knowledge in our pockets, yet couldn't find north if our phones died. This erosion of environmental literacy carries real consequences. In 2019, a US Navy destroyer collided with a tanker because officers relied solely on digital charts that didn't show nearby ships, a mistake any Polynesian navigator would have avoided by reading wave interference patterns. When solar flares knocked out GPS across Scandinavia in 2022, reindeer herders using traditional wind reading techniques guided stranded hikers to safety while tech-dependent rescuers floundered. Even farmers now struggle to predict rain without apps, despite their grandparents having read the signs in pinecone scales and bird behavior. The very tools designed to make us self-sufficient have made us helpless, outsourcing skills that once defined human adaptability. Yet hope emerges from unexpected places. The US Coast Guard now trains cadets in celestial navigation again, not as backup but as cognitive conditioning, forcing brains to engage with the physical world rather than passive screen watching. Airlines are reviving manual flying hours to combat autopilot complacency. Meanwhile, tech giants are turning to indigenous knowledge to fix their system's blind spots. Google Maps now incorporates tidal patterns shared by Marshallese elders to predict flooded roads, while Microsoft's Planetary Computer project uses Aboriginal fire management principles to model climate resilience. The lesson is clear: the future isn't about choosing between silicon and star lore, but weaving them together. The most promising experiments live at this intersection. In Alaska, Yupik hunters overlay satellite ice maps with traditional wind charts to track shrinking seal habitats. Norwegian fishermen blend sonar with Old Norse current rhymes to locate herring schools migrating earlier due to warming seas. Even NASA has taken note. Their astronauts study Polynesian non-instrument navigation to hone situational awareness for lunar missions, recognizing that no amount of technology replaces the human capacity to read subtle environmental cues. This hybrid approach reveals technology's proper role, not as a crutch but as a bridge back to deeper wisdom. Smartphones can teach us to identify constellations, but only lived experience lets you feel how the Pleiades' position shifts with seasonal winds. Apps can predict tides, but they can't replicate the Marshallese navigator who tastes salt spray and knows exactly how far the reef lies beneath. The goal isn't to abandon progress, but to reclaim what we surrendered along the way, the ability to navigate not just space, but our place within it. Perhaps that's the ultimate destination point. Ancient tools worked because they demanded participation. You couldn't just consult a camel or sunstone passively. You had to engage with the living world. Modern navigation often feels like watching a movie, while traditional wayfinding was more like dancing, a continuous, embodied dialogue. The path forward may lie in remembering that satellites are tools, not substitutes, that artificial intelligence works best when partnered with ancestral intelligence. After all, the stars that guided Magellan still shine, the waves that carried the Hercules still roll, and the wind still carries whispers older than the first microchip. The question is whether we'll silence those voices entirely or finally learn to listen again. In a classroom on the shores of Oahu, teenagers aren't just studying stars, they're memorizing them with their bodies. The Hawaiian Voyaging Society's Starlab program teaches students to navigate by lying on their backs, tracing constellations with outstretched arms until the patterns live in their muscles. Across the Pacific in New Zealand, Maori elders guide children to carve miniature waka canoes while reciting centuries-old chants that encode tidal patterns. These aren't cultural relics gathering dust in museums. They're living skills being honed for a precarious future. Norway's coastal schools have taken Viking navigation beyond the history books. Children as young as 8 learn to estimate latitude using nothing but a wooden disc and the noonday sun, techniques their ancestors used to colonize Iceland. But here's the twist. Teachers report these students outperform their peers in spatial reasoning and environmental science. Handling a sun compass isn't just about learning the past. It's rewiring young brains to see the physical world as a dynamic, solvable puzzle. This renaissance isn't confined to indigenous communities. MIT's engineering department now hosts an annual low-tech navigation challenge where students ditch GPS to cross Boston Harbor using Polynesian wave piloting techniques. Contestants must interpret swell patterns, bird behavior, and bioluminescence skills that proved vital when Hurricane Maria knocked out Puerto Rico's power grid in 2017. Fishermen using ancestral star paths became the island's de facto supply network, delivering aid when digital maps failed. What's emerging is a radical educational philosophy, resilience through cognitive diversity. Finland's wilderness schools blend Sami snow reading traditions with drone technology, creating hybrid navigators fluent in both satellite imagery and reindeer migration signs. In the Marshall Islands, elders teach stick chart weaving alongside coding classes not as opposites, but as complementary languages for solving problems. The goal isn't to reject modernity, but to build an intellectual arc, preserving ways of knowing that might one day save lives when algorithms falter. The urgency behind these programs crystallized during California's 2020 blackouts, when amateur astronomers revived long-forgotten comet lore to help firefighters coordinate in GPS-dead zones. Suddenly, celestial navigation wasn't quaint, it was critical infrastructure. Similar stories emerged from Australia's bushfires, where Aboriginal trackers guided evacuations using smoke patterns modern meteorology hadn't catalogued. These events revealed a terrifying gap in our technological armor. When systems fail, we've unlearned the very skills that sustained humanity for millennia. Yet the most profound impact might be psychological. Students in these programs consistently report heightened environmental awareness, noticing subtle shifts in wind direction or cloud formations that most adults ignore. A study of Hawaiian wayfinding students showed a 70% increase in ecological literacy after just one semester. They weren't just memorizing facts, they were developing what neurologists call embodied cognition, where knowledge isn't stored in abstract concepts but in sensory and motor systems. These kids don't just know the stars, they feel them. Critics argue that teaching obsolete skills wastes precious classroom time, but recent climate disasters suggest otherwise. When Typhoon Suragi disrupted Micronesia's satellite networks in 2021, it was a 16-year-old who steered his village supply boat to safety using wave patterns he'd learned in a traditional navigation summer camp. His story echoes a growing consensus among disaster preparedness experts. In an era of climate chaos, the most advanced societies may be the most fragile. The real luxury isn't unthinking dependence on technology, but the versatility to move seamlessly between digital and analog survival. Perhaps that's why these programs are spreading far beyond their cultural origins. Swiss mountaineering schools now teach Inuit snow structure analysis alongside avalanche transceivers. Arizona's desert survival courses blend Apache water finding techniques with solar still engineering. Even astronauts train with Polynesian navigators, recognizing that interstellar travel will require the same environmental acuity that once guided canoes across the Pacific. The through line is clear. The old ways aren't just history, they're the original STEM education refined through generations of trial and error. The lesson for our hyper-connected age is paradoxical. To navigate an uncertain future, we must sometimes look backward, not with nostalgia, but with the sharp-eyed pragmatism of those who depended on these skills for survival. The next generation won't face mere power outages, but rising seas, shifting magnetic poles, and solar storms that could fry satellites for years. In that world, knowing how to read a star chart or interpret wave patterns won't be quaint. it might mean the difference between thriving and becoming another cautionary tale in the annals of collapsed civilizations. The real test of education isn't just preparing students for the world we expect, but arming them with the wisdom to adapt to the world they'll actually inherit. The greatest navigators in history understood something we've nearly forgotten. True wayfinding isn't about conquering the wild, but about learning its language. Those weathered star compasses and tide charts weren't just tools, they were testaments to humility, proof that thriving requires listening as much as calculating. Today, we face storms no ancient mariner could have imagined: rising seas that erase coastlines, digital currents that drown out intuition, a world so saturated with data that we've lost the art of reading the sky. Yet the solutions might lie in the very wisdom we've cast aside. Consider how Polynesian navigators viewed mistakes. When a canoe went off course, they didn't blame the stars or the waves, they assumed their own understanding was incomplete. That mindset could revolutionize how we tackle climate change. Instead of forcing nature into submission with higher seawalls and deeper drills, what if we approached melting ice caps and shifting monsoons like wayfinders? Not as problems to fix, but as signs to interpret. Modern science is already catching up. Researchers now study Inuit sea ice dictionaries to improve climate models, while engineers mimic termite mound ventilation, a technique African tribes used for centuries to design passive cooling systems. The old ways weren't just sustainable, they were symbiotic. This isn't about nostalgia, it's about hybrid thinking. The Marshall Islanders who today pair GPS with stick charts aren't clinging to the past, they're building resilience. When a solar flare knocks out satellites, their wave pilots become the backup network. Similarly, Finnish architects now combine software with Viking timber joinery to create earthquake-resistant buildings that flex rather than fracture. The lesson is clear: the future belongs to those who can toggle between silicon and intuition, between algorithms and ancestral memory. The most urgent navigation, though, may be societal. Like the Maya astronomers who tracked Venus to time crop plantings, we need to reconnect cycles, to see how economic policies ripple through ecosystems, how cultural amnesia fuels environmental recklessness. Ancient tools remind us that every decision exists within a web. The Viking sunstone didn't just point north, it tied seafarers to seasons, tides, and celestial stories. Our modern tools, from social media to supply chains, rarely offer such context. We've gained precision but lost orientation. Perhaps that's why these ancient methods are resurfacing in unexpected places. Silicon Valley futurists study Aboriginal songlines to design more intuitive AI. Pediatricians teach star compass exercises to children with attention disorders, strengthening spatial reasoning. Even astronauts train with Polynesian navigators, recognizing that Mars missions will demand the same environmental attunement that once guided canoes across the Pacific. The pattern is unmistakable. The skills we discarded as obsolete are becoming survival skills for the 21st century. The voyage ahead won't follow straight lines. Like the Polynesians riding counter currents or the Inuit deciphering snow's whispers, we'll need to navigate by nuance, balancing technology with tradition, innovation with continuity. Those ancient wooden tools hold a final secret: they were never meant to last forever. Camels wore down, sunstones cracked, stick charts frayed. Their power lay in the knowledge they represented, a living conversation between humans and the elements, constantly renewed. That's the course we must now chart, not back to the past, but forward with the wisdom the past preserved. The stars haven't changed, only our willingness to